Alright, hey guys, this is lesson 3.3, factor theorem. Alright, I've tried to make this shorter and I'm not being very successful, so watch what you can and pause it and watch the rest. Alright, so any polynomial function f of x minus k is a factor of the polynomial if and only if f of k equals 0. So that means no remainder. Alright, so since it's x plus 4, so we have to do x plus 4 equals 0 and solve for x. So x is negative 4. So we're going to put the negative 4 on the outside of the box, and then we're going to look at our exponents. 4, 2, 1, none. So since we skipped 3, it's going to be 3, 0, negative 48, 8, 32. We're going to drop the 3, multiply, add, multiply, add, multiply, add, multiply, add. And then there's no remainder, so yes, negative 4 is a factor of that polynomial. So now we're going to try this one. So 5, 4, 3, 2, 1, none. So we're going to just put our coefficients under here. 1, 6, 11, 12, 5, negative 20. We're going to drop the 1, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add. Alright, example 2, factoring a polynomial given a 0. Given a 0 means that the remainder should be 0. So we're going to put 5 on the outside of the box. We're going to put 6, negative 37, 32, 15 under the box because our exponents are in descending order and nothing is missing. Drop the 6, multiply, add, multiply, add, multiply, and our remainder is 0. Okay, because this was 6x cubed, this means this is 6x squared minus 7x minus 3. Okay, if we factor this using my x, 6 goes at the top, 6 times negative 3 goes at the bottom, and we need factors of negative 18 that give us negative 7. So negative 9 and 2. Then 6 over negative 9, 6 over 2, then we simplify. So 2 over negative 3, 3 over 1. So I have 2x minus 3, 3x plus 1. Those are my two linear factors, and we can't forget the 5. So we have to flip the sign on that. So x minus 5. Those are our three linear factors. Okay, the rational zeros theorem. If p over q is a rational number written in lowest terms, and if p over q is a 0 of f, a polynomial function with integer coefficients, the p is a factor of the constant term, and q is a factor of the leading coefficient. These help you to find numbers that you can divide by when you aren't given one. So p in this case is 4, so we're going to do the factors of 4. Plus or minus 1, plus or minus 2, plus or minus 4, because we don't know if we have two negatives or two positives. Q is 8, so our factors of 8, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. So to find p over q, we just make our pairs. So 1 over 1 is 1. 1 over 2 is a half. 1 over 4 is a fourth. 1 over 8 is an eighth. Then we do 2 over 1 is 2. 2 over 2 is 1. So we already have that. 2 over 4 is a half. We already have that. 2 over 8 is a fourth. We already have that. Then we do 4 over 1. 4 over 2 is 2. We have that. 4 over 4 is 1. We have that. 4 over 4 is 8. We have that. So these are our possible numbers that we can divide by. Okay, so we're going to pick one and try it. So let's pick -1. Let's pick +1. Okay, so we have 8, -26, -27, 11, and 4. So I drop the 8. I multiply. I add. I multiply. I add, multiply. I multiply. Okay, so this has a remainder, so this does not work. So now we're going to try again. Let's try -1. Okay, so that got to give us a remainder of 0, so that works. So now we need to try another number. Let's try +4. Drop the 8, multiply, add, multiply, add, multiply, add. Okay, so that works. So now we have 8x squared minus 2x minus 1. So we have to factor that into linear terms. You know 2 times 4 is 8 with a difference of 2, so that's going to work. So we have 4x minus 1 and 2x minus 1. Okay, we want the 4 to be negative because the 2 is negative, so this has to be positive. So those are 2 linear factors. Because it's to the 4th power, there will be 4 linear factors. So we're going to flip the sign on the 4, so x minus 4. Flip the sign on the 1, so x plus 1. So there are your 4 linear factors. Okay, we're going to do a couple of different problems instead of these problems. So it says, for the following, we're going to do the one off your homework. It says, for the following polynomial function, find all zeros in their multiplicities. This is like number 15 on your homework. So I have f of x equals x minus 2 to the 4th power and x squared minus 5. So multiplicity means how many times. So if I do x minus 2 equals 0, so x equals 2 with a multiplicity of 4, because the exponent's 4. If I do x squared minus 5 equals 0, x squared equals 5, and if we square root both sides, x equals plus or minus the square root of 5. And then for number 16, oops. F of x equals 9 times x minus 2 squared, 3x plus 1, and x squared minus 9. This is an example of 15 and 16. You may have different numbers. So we don't have to do anything with the 9 because it doesn't have a variable. So x minus 2 equals 0. So x equals 2. Multiplicity 2 because of the exponent. 3x plus 1 equals 0. 3x is negative 1. X is negative 1/3. X squared minus 9 equals 0. X squared equals 9. Square root. X equals plus or minus 3. Okay, that's all you need to know for lesson 3.3.